our third example, I have a quadratic expression that is slightly different than the example before. Now this quadratic expression has a coefficient of 3 for their x squared term. So it will be very difficult to use that strategy with the diamond problem. So what I'm going to do first is I'm going to factor out the greatest common factor. The greatest common factor of 3, 21, and 36 is the greatest number that divides each of those numbers evenly. In this case, it is 3. So I'm going to rewrite this expression with the greatest common factor, and I'll get x squared, because 3 times x squared is 3x squared. Now this is going to give me a 7x, because 3 times 7x is 21x. And this one, 3 times 12 is 36. Okay, you can also do reverse thinking. You can do 3x squared divided by 3 to get x squared, 21x divided by 3 to get 7x, and 36 divided by 3 to get 12. Now this expression is in very similar form because the coefficient of the x squared term is 1. So I'm going to rewrite it as the product of two binomials, and I'm going to use a diamond problem to fill in the blanks. Okay, so now the product of the x squared term coefficient and the constant is 1 times 12, so it's 12. The sum is that x term coefficient, which is 7. I'm thinking of two numbers that when I multiply them together will give me 12. When I add them together will give me 7. And I came up with 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. Now, again, since the coefficient of x squared is 1, I can just write the first term of the binomial as x, and then transfer all of these numbers inside each of the binomial. This is a positive 3, so 3 is added to an x. This is a positive 4, so 4 is added to an x. This is my final product, which represents complete factorization of that particular quadratic expression. Yay!